Hello friends, in Mossbauer spectroscopy, my position is Mossbauer spectrometer. First I introduce you to some experimental techniques used in it. The integral part of the experimental technique is source and absorber. Source means a solid matrix containing the excited nuclei of a given isotope called the source. A solid matrix means a crystal lattice, and a second crystal lattice containing the same isotope in the ground state called the absorber. The strength of the resonant absorption is decided by the source and absorber. That is, the amount of overlapping of energy profiles for source and absorber decides the strength of the resonant absorption. This figure shows the amount of overlapping of energy profiles of source and absorber. And the movement of the source and absorber related to each other with a velocity v. That means source moves towards the absorber, the velocity v increases, and the source moves away from the absorber, the velocity v decreases. And this velocity v produces a shift in frequency, that is Doppler shift in frequency, which is denoted by delta nu. Delta nu is equal to v by c into nu, where c is the velocity of the light and nu is the frequency of the gamma ray. If the effective resonance energies for source and absorber exactly match at a particular velocity v, at that point the resonant absorption will be at a maximum. Cobalt 57 with atomic number 27 is used as the source in Mossbauer spectrometer. It is a radioactive element which undergoes electron capture, produces Fe57. It is excited ion. That excited ion drops to the ground state, that is Fe57. In this transmission, it emits gamma ray, and the study of the gamma ray emission and its subsequent emission is called the Mossbauer spectroscopy. And to detect the gamma ray transmission is done by the Mossbauer spectrometer. This figure shows the energy diagram of a Mossbauer transition. The radioactive element cobalt 57 with atomic number 27 and spin value 7/2 is unstable, so it decays naturally through a electron capture decay to the Fe57 with atomic number 26 and spin value 5/2 with an energy 136.4 kilo-electron-volt is in the second excited state. Here, there is two transition is possible from the second excited state, that represented by gamma 1 and gamma 2, with a chance percentage of 19% and 10% respectively. The gamma 1 transition is from the second excited state to the first excited state with an energy level 14.4 kilo-electron-volt and spin value 3/2. And gamma 2 is the direct transition from the second excited state to the ground state. The Fe57 in the first excited state decay to the ground state Fe57, and it will emit the gamma ray. This gamma ray absorbed by the absorber, and the detector will detect the gamma ray.